Today, we will discuss topics regarding acids and bases. For starters, acids are categorized as sour, while bases are slippery. But did you know that there is more to acids and bases than what meets the eye? When they meet together, they comprise a large systems of electrons and protons. While thinking about it, we see acids as the spenders and the bases as the acceptors. Currently, there are three theories regarding acids and bases: the Arrhenius theory, the Brownstedt-Lowry theory, and the Lewis theory. Let's talk about the Arrhenius theory. Introduced in 1887 by Swedish scientist Svante Arrhenius, the Arrhenius theory states that acids are substances that dissociate in water to yield electrically charged atoms or molecules called ions, one of which is a hydrogen ion H+. And that base ionizes some water to yield hydroxide ions OH negative. It is known that hydrogen ions cannot exist alone in water solution. Rather, it exists in a combined state with the water molecule as the hydronium ion H3O+. In practice, the hydronium ion is still customarily referred to as the hydrogen ion. Furthermore, such acids and bases may be classified as strong or weak acids and bases depending on the hydrogen ion or hydroxide ion concentration produced in a solution. Now for the Brownstedt-Lowry theory. A Brownstedt-Lowry acid is any species that is capable of donating a proton. A Brownstedt-Lowry base is any species that is capable of accepting a proton, which requires a lone pair of electrons to bond to the H+. Water is amphoteric, which means it can act as both a Brownstedt-Lowry acid and a Brownstedt-Lowry base. strong acids and strong bases ionize completely in an aqueous solution, while weak acids and weak bases ionize partially. The conjugate base of a Bronsted-Lowry acid is a species formed after an acid donates a proton. The conjugate acid of a Bronsted-Lowry base is a species formed after a base accepts a proton. These two species in a conjugate acid-base pair have the same molecular formula, except the acid has an extra H plus compared to the conjugate base. So far, we learned that an Arrhenius acid is any species that can increase the concentration of H plus in a aqueous solution. An Arrhenius base is any species that can increase the concentration of a OH negative aqueous solution. A major limitation of Arrhenius theory is that we can only describe the acid-base behavior in water. The Bronsted-Lowry theory describes acid-base interactions in terms of proton transfer between chemical species. A Bronsted-Lowry acid is any species that can donate a proton H+. A Bronsted-Lowry base is any species that can accept a proton. In terms of chemical structure, this means that any Bronsted-Lowry acids must contain a hydrogen that can dissociate as H+. To accept a proton, a Bronsted-Lowry base must have at least one lone pair of electrons to form a new bond with the proton. Lastly, for the Lewis theory. Lewis' definition of acids and bases in 1923 by G.N. Lewis suggested another way of looking at the reaction between H+ and OH negative ions. In the Bronsted model, the OH negative ion is the active species in the reaction. It accepts an H+ ion to form a covalent bond. In the Lewis model, the H+ ion is the active species. It accepts a pair of electrons from the OH negative ion to form a covalent bond.